Hey guys, welcome back to my channel. Today we're going to continue with logarithmic properties, and we're going to start off by talking about the power rule. And the power rule states that if we have a log with base a of x raised to some power p, that we can rewrite it using the power rule of that exponent p times the log of x base a. So basically we take the exponent of our argument and bring it down in front and multiply the log with that exponent. And so we're going to apply that in a few of our examples here. So the directions are asking us to expand each expression. So our first example is that we have says the log of 3 times 2 cubed. So first what we're going to do is we see that we have 3 times 2, so we're going to use the power rule, we're going to use the product rule to break them up. So this is going to be the log of 3 plus the log of 2 cubed. Now we can apply the power rule to the second log. Okay, so the first log, you just bring it down. So we have the log of 3 plus the 2 is, or the 3 is in my exponent, so I'm going to bring that 3 right on down into the front. So this would be 3 times the log of 2. So that's how we expanded the expression, first using the product rule and then using the power rule. All right, now we have the log of x, y, z squared. So first, by expanding it, we need to apply the product rule. So we're going to have the log of x plus the log of y plus the log of z squared. Now we're going to apply the product or the power rule to the third term. So we're going to write the first two as normal. So we have the log of x plus the log of y plus the power of the z is 2, so we're going to bring that down in front. So it's going to be 2 times the log of z. We have 2 more examples here. So then we have the log of 6 over 11 raised to the 5th power. Okay. So first things first, we can go ahead, since the 5 is, the power is on the outside, and it's being applied to both the 6 and the 11, we're going to bring that down. So we're going to apply the power rule first. So we're going to have 5 times the log of 6 over 11. Okay. Now what we're going to do is apply the quotient rule, but this 5 is being multiplied by this whole thing, by the log of 6 over 11. Our 5 will be multiplied by both the log of 6 and the log of 11. And I'll show you. So we have 5. I'm going to have an open bracket here. Be the log of 6 minus the log of 11. Okay. Now we're going to distribute the 5 into each of these logs. Okay. So this becomes 5 times the log of 6 minus 5 times the log of 11. All right, now our last example in this section says we have a log of u to the 4th power over v to the 20th power with a base of 3. Here we're going to apply our quotient rule first because we are dividing. Okay, so we have the log of u to the 4th power base 3 minus the log of v to the 20th power with a base of 3. Now we apply the power rule. So we'll bring the 4 here down in front and then 20 down in front, okay? So the first log is 4 times the log of u base 3 minus 20 times the log of v base 3. All right. Now we're going to apply the power rule. In the directions for our examples, it's asking us to condense each expression. So we're going to take these many logs and we're going to combine it into one log. Okay, so let's see here. All right, so we have the log of 3 plus 3 times the log of 2. Okay. What we're do here, we're going to actually reverse it. We have to apply the power rule first to bring that 3 back up to the top before we can go further. So here we're going to have the log of 3 plus the log of 2 cubed. Now we can apply the product rule because we're adding both of these logs. So here we have the log of 3 times 2 cubed. Now we have the log of x plus the log of y plus 2 times the log of z. And here we see that these are all pluses, so it's going to be a string of the product rule. But first, we see that we have a 2 that's being multiplied by this log, so we have to take the 2 and we have to use the power rule first. Okay, so we're going to rewrite the first. We have the log of x plus the log of y plus the log of z squared. Now we can use the product rule to to condense or combine the 3 logs. We have the log of x times y times z squared. The last 2 examples here, we have 5 times the log of 6 minus 5 times the log of 11. So first things first, we see that both of these logs have a common factor of 5, so we're going to factor out the 5 times the log of 6 minus the log of 11. Now we can apply the quotient rule to combine the log of 6 and the log of 11. 5 times the log of 6 over 11. Now we apply the power rule to bring the 5 up here to the power. So this is the log of 6 over 11 raised to the 5th power. And the last example in this section is we have 4 times the log of u base 3 minus 20 times the log of v base 3. So we see that both of them have the same base, but they have a multiplier out here. So we're going to first apply the power rule to put it back in the exponent. So we have the log of u to the 4th power with a base of 3 minus the log of v to the 20th power with a base of 3, sorry. Now we can apply the quotient rule. So we're going to have the log of u to the 4th power over v to the 20th power, right, with a base of 3. All right, now we're actually going to take a look at the change of base rule. So what this says is that if we have a log of x base a, then we can change this base to the log of x with base b divided by the log of a base b. So the argument becomes the argument in the numerator, and the original base becomes the argument in the denominator, right, of the argument in the denominator, and b is whatever kind of you choose. Usually it's 10, because our calculator, if we use calculators, our calculators understand base 10. They don't understand really anything other than base 10, so we have to convert it to a log of base 10. But it can be anything as far as like when you're applying these principles, okay? Now we're going to apply this rule, the change of base rule, okay? Our directions say to apply the change of base rule to each expression, okay? So we're going to use the change of base rule. So by using the change of base, we have the log of, well, the argument is 5, okay, and we're going to use a change. We're going to use base 10, okay. This becomes the log of 5 divided by the log of 4. Same thing with our next example. We have the log of 13 base 6. We want to change it with a base of 10. So we have this becomes a log of 13 divided by the log of 6. We have the log of 3.5 with base 10. So this becomes the log of 3.5 divided by the log of 4. And now we have the log of 8.7 base 7. So when we use the change of base rule, this becomes the log of 8.7 over the log of 7. And in both of these, we use base 10. All right, the last property we're going to take a look at today is the equality rule. And the equality rule states that if the log of x base a is equal to the log of y base a, then x must equal y. But we also have some boundaries. A must be positive and a must not equal 1. Additionally, x and y must both be greater than 0. In other words, they must be positive. So we're going to apply that to our examples below. And so, but first, the directions are asking us to apply the equality rule to each expression. All right. So we have the log of x base 2 is equal to the log of 14 base 2. So first things first, we notice that our bases are equal, okay, which is also here. Our bases must be equal, must be the same. Then I can set both of the arguments equal to each other. Okay, so this must say that x is equal to 14. And in our next example, okay, we have the log of the quantity 8 minus 2 base 8 is equal to the log of 5 base 8. First things first, I must make sure that my bases are the same, and they are. They're the same, and they are greater than 0, and they're not equal to 1. So that is a positive, right? That's a plus, check mark, rather. Then I can set both of my arguments equal to each other. X minus 2 must equal 5. So when I add 2 to both sides, I get x is equal to 7. And if I plug 7 in here, I get 7 minus 2, and that is 5. So we know that that is correct. Let's take a look at a couple more examples here. The log of the quantity 2x minus 3 base 2 is equal to the log of the quantity x plus 4 base 2. So first things first, I need to make sure that my bases are equal. They're the same. Must also make sure that they are positive and not equal to 1. So it meets both of those criteria. So now I will set both of the arguments equal to each other and solve for x in this case. So we have 2x minus 3 is equal to x plus 4. I'm going to subtract 4 from both sides, or I'm sorry, we're going to subtract x from both sides, and at the same time, I'm going to add 3 to both sides. So I have x, this goes away, is equal to the x minus x goes away on the right side, and then 4 plus 3 is 7. If I substitute 7 in for x here, I get 14 minus 3, and that is equal to 11. And then if I substitute 7 into the other side, you get 7 plus 4 is 11. So 11 does in fact equal 11. In the next example, I have the log of 8 base b plus the log of x squared base b is equal to the log of x base b. Now, this one looks a little different from the one we had before because we have this plus here in the middle. We just don't have a log equal to a log. We have the sum of 2 logs is equal to a log. So we have to condense or combine these two first before we do anything. And we see here, first of all, they have the same base, right? Which is a requirement before we can either add or subtract bases, or combine them rather. So to do this, we're going to apply the product rule. So this becomes the log of 8 times x squared equal to the log of x base b, and this is also base b. Now that we have a log equal to a log, right, use the equality rule. Or, well, first of all, we have a couple things we have to do. First of all, we have to make sure that the bases are equal. They're the same. In this case, they're a variable, so we have to say given or b must be positive and it cannot equal 1. So we have to put those boundaries in ourselves. Then with that, then we go, okay, let's set the arguments equal to each other. So 8x squared must equal x, okay? I can divide through by 0, divide through by x. So if I do that, if I divide both sides by x, right, then I'll get 8x is equal to 1, and then x is equal to 1/8. And in order for that to be correct, right, we have to go back up here and go, okay, there's also some stipulation about our arguments. And so up here it states that x and y must be greater than 0. They must be positive. That's all that says. So here, x is in fact positive, so this is an answer. So that concludes today's video. We talked about our power rule, we talked about the change of base rule, and we even went over the equality rule. If you found this video helpful, please click the like button, subscribe to my channel for more videos like this. If you think someone else could benefit from this video, please share it. In the next video, we will continue with logarithms. So I will see you guys in the next video. Have a great day.